Question number 8 of the PhilNITS FE morning portion of the exam. In this question, we are given two microprocessors, a 32-bit CPU capable of executing each of the 32-bit, 16-bit, and 8-bit long instructions in one cycle, and another CPU which is a 16-bit CPU capable of executing each of 16-bit and 8-bit long instructions in one cycle. So again, we have two CPUs, a 32-bit CPU and a 16-bit CPU. The 16-bit CPU can execute a 32-bit long instruction in two cycles, and the situation is that the appearance ratio of 32-bit long instructions is 40%, and of 16-bit long instructions is 40% as well, and finally of 8-bit long instructions it's 20% respectively. What is the percentage improvement in total execution time with the 32-bit CPU compared to the 16-bit CPU? Here, both the 32-bit and 16-bit CPU operate at the same clock speed and have the same performance except for the executable instruction length in one cycle. Again, we are being asked what is the percentage improvement in total execution time with the 32-bit CPU compared to the 16-bit CPU. Okay, I ended up choosing the wrong answer, which is B, but I think it's quite close to the correct answer, which is A, somewhat, if we look at the other choices, and we need to explain to how I arrived with the wrong answer, and later on how we can arrive at the correct answer. Okay, and it's interesting to point out that some of the choices would have fractions, and therefore if our answer in this case is a whole number like 40, we should at least wonder why there are fractions among the choices as well. And maybe that could help us remember to review our answer, but also to check whether we are doing it in a way that is enough or that is sufficient to get hold of the correct answer. Although maybe because I do remember that there are exams where they just put all the choices in a way that shouldn't let you think too much. That if you begin to have doubts with your answer, you'll end up making more mistakes. So sometimes there's that thing too. Although in this case, it looks like the exam somehow gives you an idea what the choices are, at least in the sense that you'll have a better understanding of what could be the thing that they're looking for and how to arrive with that thing. Because if you have a fraction like this, it looks like you have to do some type of division, some type of additional equation that turned out I was not able to do. So if we look at how I arrived at letter B, we can see here that I put here the things that we have read a while ago, what a 32-bit CPU can do in one cycle, and these are the set of instructions, and a 16-bit CPU in one cycle can do these, but it would take two cycles to complete a 32-bit, or in this case a 32 bit long instruction. Okay, so take note that there's a CPU and there's a set of instructions. I think in my case that wasn't too difficult to distinguish because we can put them in a way that would at least be clearer to understand how things are. Like for example, the description says that a 32-bit set of instructions would have a ratio of 40%, and 16 would have 40 as well, and 8 would have 20. And we are being asked, what is the percentage improvement when we compare a 32-bit with a 16-bit CPU? And the next thing that we can do is to create this diagram where it says that, okay, so we're talking about a 32-bit CPU. We'll add 40, 40, 20 in this way based on the description here. And what we can see is that this should be one cycle. However, for a 16-bit CPU, we need 2 cycles, right? Because we can't finish the, I think it was the 32 set of instructions, 32-bit set of instructions in one cycle, so we'll need another cycle. And what I wrote was, okay, 40 here, and for the next cycle, we'll need another 40. Okay, and I thought that, well, it looks like there's a 40% improvement if we're using a 32-bit, because we can finish the whole thing in one cycle. We don't need 2 cycles anymore. But it turns out we need to get the percentage improvement, and it turns out too that we'll need some kind of equation to get hold of that answer. And if we look at the equation from Math is Fun, the steps to get hold of the correct answer, which is letter A, seem to be pointing to this idea that we need to see the change, the percentage change, and then from there get hold of the percentage improvement. Okay, and for example, we used up 2 cycles for the 16-bit, and the total will be 140. While for a 32-bit CPU, we can finish the whole thing in 1 cycle, and that's only 100%, instead of the 140 due to the 2 cycles. So we need to see what would be the percentage change, and from the Maths is Fun explanation, what we need to do is subtract 140 minus 100 divided by 140 again, because we're going for the 16-bit CPU. How is it performing? Okay, and that's how we will get 40 divided by 140. And next, what we need to do is divide these to see what answer we'll get. And as you can see, I did the long division, because remember, we're not supposed to use any calculators nor check websites online, except that in this case, to find out how we can get hold of letter A, the correct answer, I needed to look into Maths is Fun to see if we can have some clue, some idea how to solve it. Now, if we are dividing 40 by 140, we should remember the steps to do the long division. And for example, in this case, how many 140s are there in 40? We know that 40 is too small. We need another 0. That's why in this part here, we would have the decimal point to signify that we can add a 0, but we'll need a decimal point here, because 40 by itself won't be enough for a 140 number to divide. So in this case, next we need to do is to do multiplication. And what I did first was, how many 140s are there in 400? I thought maybe 3. But turns out that if you do the math, 0 times 3, 0, 4 times 3 is 12. Carry over the 1 here, 3 times 1 is 4, 420. After testing the idea, found out that 420 is too big. We need something smaller, and it looks like it's going to be 2. So 2 times 0, 0. 4 times 2 is 8. and multiply 1 and 2 together, we get 280. That's how we get 280 here, and we put the 2 here. 2 times 140 is 280. Alright, now we need to do a subtraction. 400 minus 280 is 0, goes down here, and then 10 minus 8. Okay, remember that part about subtraction. 10 minus 8 is 2, and this one becomes 3. 3 minus 2 is 1, so 120. And the next question comes again. How many 140s are there in 120? 120 is too small, we need another 0. That's why we put a 0 here. And the question now is, how many 140s are there in 1200? So we need to check how many are there. And I thought, okay, maybe 8, because 8 times 1 seems high enough. And of course we have the 4 here. Maybe it will add up to something that will get us a number close to 1200, if not 1200. And what we can see is 140 times 8. 8 times 0 is 0. 8 times 4, or 4 times 8 is 32. Put a 3 here, carry over there. And 8 plus 3 is 11. So 1120, we put it here, and 8 goes here. And now what we need to do is do a subtraction. 1200 minus 1120 gives us what? Gives us 80. Okay, 1200 minus 1120. And then once we get the 80 here, how many 140s are there in 80? We can see that it's too small. 80, we need another 0. That's why we get 800 now here. So the question is, how many 140s are there in 800? And what we can find is that I first checked, what about 7? 7 140s in 800, and turns out that if we do the multiplication, we get 980, and it's too big. So what about 5 maybe? We will get 140 times 5 is 0, 20, 0, 2. Here, carry over the 2. And 1 times 5 is 5 plus 2, 700. So turns out this should be 5. So that will have 700 here. And subtract these two, we get 100. But again, how many 140s are there in 100? 100 is too small, we need another 0. So how many 140s are there in 1000? Turns out that the computation I did to check what would be the answer previously turns out to be what we'll be using now, which is 7 times 140 gives us 980. So that's how we got 980 here, and the 7 here goes after 5. Now we can still continue on and on, but remember that the choice doesn't need all the other numbers anymore. And it looks like this is the answer to answer in letter A, I mean. But remember that we still need to do a multiplication. We need to do a times 100 here, so that this will be 28 times 57%. We need to do the times 100 because we need to get the percent of the improvement. And now we can get hold of the correct answer, which is letter A, by doing these steps, which gives us the percentage improvement when we compare a 32-bit CPU with a 16-bit CPU.